Welcome to Ndumi's Learning Zone, where I make maths and science very, very easy. So today we shall be diving into a new concept, which is change in momentum. In the previous video, we looked at momentum and we looked at the equation of momentum, which is just momentum is equal to the mass of an object multiplied by its velocity. And we also looked at the units of momentum, which is just kilograms meters per second. And we also talked that momentum is a vector quantity. Therefore, if it's a vector quantity, we should expect to have magnitude and direction. Alright. Now, let's now look at the new concept, which is change in momentum. So when the word change comes into your mind, what you should think of is what you have in the final minus what you have in the initial. So basically, we denote this particular change as delta, which delta means final minus initial. So it's delta momentum is equal to mass multiplied by the velocity final minus your mass multiplied by my velocity initial. If you check very well, if I can factorize here, I can take out my mass as a common factor and I have Vf minus Vi. In some textbooks, they just say delta P is equal to delta V. Alright, so this is just the change in momentum and its units is just kilogram meters per second. Now, there are also another set of units which is newtons second, but we'll talk about this one in the next video possibly. Now, let us dive into a question such that we understand what is this particular concept. Right. In this particular case, we have a car. Let me try to zoom in a bit. Right, yeah. So we have a car. This particular car is moving in the east direction, or we can say it is moving towards the right. So it is moving at a speed of 5 meters per second. As the car is moving, the driver decides to hit the acceleration such that the car increases its velocity. So after a few meters, the car has moved forward and it has increased its velocity. Alright, so what is the change in momentum for this particular car? Alright, my first thing I say, delta P is equal to my mass multiplied by my delta V. Alright, the mass of the car is constant. The mass of the car is constant, which is 1000 kilograms. So let's move on. This is just going to be delta P is equal to my mass of my car, 1000 multiply, and here I've reached a train smash. Why am I saying this? When it comes to mechanics, paper 1 especially, you need to choose a direction. You need to choose a direction. I'm emphasizing this. I am going to just choose to the right as positive. To the right as positive. So my final velocity is 10 meters per second and my car was still moving towards the right. So this is just going to be positive 10. Minus my car was moving in the right direction. It was moving in the right direction initially. Here is the speed at 5 meters per second. So this is just going to be 5. And this is just 1000 multiplied by 5. So my change in momentum is just 5000 kilogram meters per second. Since I got a positive answer, I'm going to say to the right. And then you're done. Let's now look at the final example. Here, basically, let me erase this such that you're not confused. Here, basically, let me try to explain what we have here. This is a ball which is 50 grams. It is thrown at an east direction, or it is thrown to the right at a speed of 2 meters per second. The ball then bounces on this particular wall. This is a wall. It bounces on this particular wall and then it moves backwards at a speed of 1.5 meters per second. So the question is, what is the change in momentum? So what happened? It threw the ball, it bounced on the wall. After that, the ball moved back at the speed of 1.5 meters per second. The first thing you should do in physics paper 1, our mass must always be in kilograms. So once your mass is in gram, you need to convert your mass from grams into kilograms. Once you work with those kilograms, you are going to get an incorrect answer. So in order for me to convert 50 grams into kilograms, we need to divide by 1000. So this is just going to be, this is my mass conversion, 50 grams. If we divide by 1000, this is just equal to 0.05 kgs. Now I have everything, so therefore I am able to calculate the change in momentum. So the change in momentum is just delta momentum is equal to my mass minus my mass multiplied by my final velocity minus my mass multiplied by my initial velocity. Alright, so this in essential terms is just, this is just the same thing as delta V. It's the same thing. Alright, I have my mass as 0.05. My final velocity, my ball, let me explain again. My ball was thrown in this direction, it hits the wall, and it moved back at a speed of 1.5 meters per second. I'm emphasizing this again. You must always choose a direction. So I'll just choose right as positive. So since right is positive, my final velocity, my ball was moving 1.5 meters per second to the left, or to the west, to the left. So since I chose right as positive, that means left is negative. So this is just going to be negative 1.5 minus my initial velocity. My ball was thrown at a speed of 2 meters per second to the right, and I chose right as positive. So this is just going to be 2. Let us punch on our calculators and see what answer do we get. The answer which I get is negative 0.175. But this is not your final answer. Remember, you have to have the magnitude and your direction. This negative sign is just indicating direction. Remember, I said right is positive. So therefore, since I got a negative answer, this is just going to be 0.175 kilograms meters per second to the left. And this is my final answer. Please like, share, and subscribe, and comment down below for more and more videos. Thank you very much, guys.